till last lecture we have learned the basic ideas of area under curve. We have learned one concept of forming area with x-axis, another concept of forming area with y-axis, and also we have learned when would the integral become negative and how to counter it by balancing the plus minus signs. Today we will learn a new concept which is area between two curves. If two curves are given, how to find the area between those two curves. Okay? Can we start? So, as I keep saying, if you have conceptual clarity, you can design your own formulae, you can design your own methods. So, conceptual clarity is very, very important, and after that developing problem solving skills is the next important step. Okay? So, here let us say we want to find the area between two curves. So, let us take the curves as f of x and g of x. Between these two we want to find the area. So, that means these two curves are actually forming two boundaries. We need another boundary or at least two boundaries, at most two boundaries to form the area here. So, in this scenario, f of x and g of x are forming two boundaries, we need two more boundaries are given by x equal to a and x equal to b. Between these two we want to find area. So, how do we do that? For that, understand this simple idea. Suppose let us say there is x axis here and there is this curve f of x, and between x equal to a and x equal to b, if I find the area, then I will get this area, right. How do we find the area here? By taking integral of a to b f of x dx. So, in this particular situation f of x is above x axis, let us assume that it is above x axis. Now, let us say there is another function which is g of x, let us say this is my g of x function, and I want to find the area formed by g of x with x axis. So, which area am I talking about? This is the area that I am talking about. To get this area, we do a to b integral g of x dx, right. Now, if I subtract the red area from the blue area, I will get the area between f of x and g of x. That means basically I am subtracting one integral from the other integral, which also means we can write this as integral of f of x minus g of x dx, integral going from a to b. So, what is the idea or property that I have used? I have used the property of distribution of integrals. Okay. So, basically what is the idea here? To find the area between any two curves, we have to subtract one curve from the other curve and integrate it. That is it, that is the line. Now, how to choose which to be subtracted, which to be added, which to have plus sign, which to have minus sign. Whatever is the function which is above, that should be the plus sign, and whatever is the function that is below, that should contain minus sign. Now, even if the functions are below x axis, even if we take a scenario like this, let us say this is my x axis, this is my f of x and this is my g of x, and I want to find the area starting from x equal to a to x equal to b, area between f of x and g of x. Let us say I want to find this area. So, here also what you do is above function minus below function, if you do it, you will get the area with positive sign only, because here f of x is less positive and g of x is more positive. So, if I subtract g of x from f of x, naturally we are getting a positive value there. So, that is how we get the area to be always positive if we follow this rule that we have to subtract the below function. Okay. So, that way we can understand this area between two curves using the concept of area formed with x axis. Can you make a note? Suppose if functions are intersecting, then how to handle this kind of situation? As usual, just like the last lecture, we break the integral from a to c and also from c to b. So, from a to c, if you observe, what is the function which is above? G of x is above, f of x is below. So, integral a to c, what we will do is we subtract f of x from g of x. This will give us the first area, and to get the second area, again observe here f of x is above g of x. So, what we do here is from a to b, f of x minus g of x into dx. So, here depending on which is above and which is below, we may have to take appropriate sign. That is why we always keep this mod of f of x minus g of x. The reason is because algebraically looking at functions, we do not know which is above, which is below. So, we put modulus, but if you are taking help of graphs, then if you can smartly choose the plus minus signs, then you can handle any area directly. Okay. So, basically we have understood one concept here. What is the concept? How to find area between two curves. But what is the fundamental that we used? Area formed with x axis, because if you observe, every time we have done the integration with respect to x only. But in similar lines, we can also find area between two curves using the idea of area formed with y axis. Come on, make a note of this, we will discuss that. Okay. Now, let us observe the same thing, but with area formed with y axis. So, here also if I use this integral a to b f of y dy. So, basically we have to write x in terms of y, you already have known this idea. If I do this, I will get the entire area starting from this y axis till the f of y curve. But if we subtract the area of g of y from this total area, I will get the required black shaded area. So, that means I may have to subtract integral a to b g of y dy. Okay. So, here with respect to y axis, if we are performing the integral, then we have to use this notation that which function is in the right side, which is in the left side. So, whatever is in the right, we have to put plus sign for that, whatever is in the left, we have to put minus sign for that. So, we always do right minus left in area formed with y axis. Area formed with x axis, in that case we always take up minus below. Okay. So, that way we can understand this sign confusion. Okay. Can we move on? So, if there is, let us say, intersecting case like this, then also we follow the same idea. We break it at a point, let us name it as C. Then from A to C, if you observe here, this is f, this is g, we may have to do f minus g dy, and when we are doing it from C to B, we may have to do it as g minus f dy. Okay. So, this way we can find the required area. Okay. So, this is the basic fundamentals of finding area between any two curves. Okay. Now, using these ideas, we will start solving some problems, but before that make a note of this. This page also. Okay. Now, let us solve some problems. So, first question is find the area bounded by y equal to log x and both coordinate axes. So, here initial 2-3 questions were from the last lecture. These are the questions which left out in the last lecture. First we finish them and we will go on to the today's lecture based questions. So, here when the phrase bounded is used, area must be having some boundaries. That is what the meaning of bounded means. Bounded means boundaries should confine the area, and area, the value of area should be finite. Only then we call it as bounded area. If the area is infinite, that means it is not actually a bounded region, it could be unbounded region. Now there is one more phrase which generally comes, which is enclosed. There are two phrases, enclosed and bounded. So first I will explain the difference between these two. Enclosed means diagram should be completely closed figure. Closed figure means there are no open ends. But bounded sometimes also could mean closed figure, but there could be special cases where area is bounded but diagram is not closed. Best example for that is this curve only. For example, if we draw the graph of this curve, okay, if we draw the graph of this curve, it is log x, you know the standard graphs. So it starts from minus infinity, cuts x axis at 1 and it goes on increasing. This is the graph of y equal to log x. Now what is the area that we are talking about? Area must be bounded by the function and coordinate axis. Both coordinate axes must be boundaries. So here if we notice, there is x axis as one boundary here and here y axis as other boundary. So the area must be this area. Now looking at this diagram, is this a closed diagram? Of course not, because here log of x graph is never touching y axis, it is not intersecting also. So that means this is an open-ended region. Open-ended region means it is not closing, but because y axis acts as an asymptote for log of x, this area will converge to a finite value. That is why this is still a bounded region. Okay, so sometimes when the word bounded comes, it need not mean that the diagram is a closed diagram. It could be an open-ended diagram just like this. Okay, so here we can understand that because these two are acting as asymptotes, area could be a finite value, it may converge to a finite value. Okay, so we are basically interested in finding this area. So first I have explained this phrase bounded in more depth because there is a chance for confusion for students. So I explained difference between enclosed and bounded. So I have taken lot of examples in the last lecture for bounded where area was completely bounded by 4 boundaries. Here if you notice there are only 3 boundaries and there is an open-ended point. So open-ended situation has to be handled by understanding the convergence of the value. Okay. So now let us go back to the basic idea of finding the area. Now if we are interested in finding the area formed with x axis, then we may have to integrate it with respect to x. The other idea could be area formed with y axis. So here I am going to explore both ideas and explain you the difference between them. Okay. Let me just take the first case, that is area formed with x axis, idea number 1. So basically we have to integrate this function. Which function? Area is equal to log x function. We are basically integrating this starting from which values? This is the initial value of x, this is the final value of x. So it must go from 0 to 1. Not so fast, there is a mistake here. What is it? Function is below x axis, so integral will be negative. We are interested in area, make it positive by multiplying with minus sign. Now we have to integrate this. So how do we integrate this? Integral of log x, you know the integral already, but if you do not know, how do we do that? By using integration by parts. So here I will just do it using indefinite style. So integral of log x dx. How do we do it? By taking 1 here. We integrate 1 and we differentiate log x. So it becomes x into log x minus integral of x into derivative of log x is 1 by x into dx, x got cancelled, and we got x into log x minus x. I will just put it here. So minus x into log x minus x going from 0 to 1. Now we have to put the limits. So when I put 1 here, I get 1 into log 1, which is going to be 0, minus 0 into log 0, and again there is one more term, so minus into minus plus 1 minus 0. But there is a problem with this term because log of 0 is not defined. Now when such situations come, what to do? We have learned this in definite integration, we have to take the limits. So basically here we are going to write it like this, value of this is 0 minus, for this we have to find limit x tending to 0, x into log x plus 1 minus 0. Now how do we find this limit? Now the problem is gone into the limits. So let us check the limit here. When we put 0 here, log of 0 is not defined, but as x approaches 0 from positive side, log of x tends to minus infinity. So basically here we are handling 0 into infinity form, and 0 into infinity form is not in the standard forms of limits. So we convert that into standard form by dividing with 1 by x, by taking this x to the denominator. So limit x tending to 0, x into log x can be written as log x divided by 1 by x. Now this is in the form of infinity by infinity. Now we can apply L'Hopital's rule here. L'Hopital means L'Hospital rule. So what is the derivative of log x? 1 by x. Derivative of 1 by x is minus 1 by x square. Now when we simplify this, we get limit of x tending to 0 minus x, which is 0. So that means this value is going to be 0. So overall we get the value as 1. So area here is 1. But if you look at this process, the process is actually complicated because of the two reasons. One is integral is not so simple. You need to know this idea. If you don't know the idea, probably you will flop there. And the second is to evaluate the limit. So this is a longer process. That is actually a combined package that comes with logarithms. Whenever in integrals, if you are facing logarithms, of course you are going to face one of these situations, and it is going to complicate your problem solving process. That is why integral or area formed with y-axis is helpful to you. Let me explain that also. This is idea number 2. So basically we are interested in finding this area. This is the area that we are interested in finding. And if we compare with the y-axis, what is the value of y here? It is minus infinity. What is the value of y here? It is 0. So that means if I find the area like this, integral of x dy, limits going from minus infinity to 0, I can get the area. Now we have a function which is y equal to log x, we have to write x as a function of y. So if y is equal to log x, then x becomes e power y. So here we can write e power y into dy, limits going from minus infinity to 0. Can we proceed? Not so fast. We need to check the sign also. Now see if the function is in the right side of y-axis or not. It is in the right side. So well and good. It is plus sign only. Okay. Now further, we know how to integrate this. Integral becomes e power y only. Limits going from minus infinity to 0. So it gives e power 0 minus e power minus infinity. This will anyways tend to 0. So we got the value as 1. See how simple it is doing with y-axis. Okay. So here we have got two ideas. One is area formed with x-axis, area formed with y-axis. Now also I will explain one more point here. Suppose if we take the cousin of this function, what is the cousin of this function? E power x function. So, suppose let us say I extend this x axis and take the graph of e power x. So, we are going to get a graph like this, and this area of e power x, okay, that means it is basically minus infinity to 0 e power x dx. This area and this area are actually exactly equal. Why are they equal? Because these two functions are inverse functions of each other. So, if I am interested in area formed by y equal to log x with x axis, basically I am interested in area formed with e power x. Okay. So, because these two are symmetric about this line y equal to x, if we know the idea of symmetry, if we understand it, we can also evaluate this integral and solve the other integral. So, in fact, what we have done here in this question, in the first idea we have done this blue area, and in the second part we have actually done this red area. Okay. So, this is the geometric significance of these two functions. Okay. So, I hope you are liking these discussions. Okay. Come on, make a note of this. This page also. Okay. Can we move on to the next question now? So, next question, find the area bounded by y equal to 2x power 4 minus x square, x axis and ordinates of the 2 points of minima. Ordinates of 2 points, ordinates means x coordinates of 2 points of minima. So, how do we do this? So, to do this, basically this question forms a platform for drawing graph of any function. So, here I am going to give you a simple glimpse of that method, but maybe in the next or next to next lectures, when I am handling the loops of the functions, I am going to explain you how to draw the graph of any function using calculus. So, here we are going to follow these tips. First is, we have to explore roots and not defined values. Roots and not defined values. This is step 1. Step 2, we are going to observe the signs. What signs are we talking about? We are talking about the signs of wavy curve method. Okay. So, these are the signs of wavy curve method. You might have learned this method of solving inequations. Next is check for the asymptotes. So, here in this function we do not get any asymptotes. So, that this step is removed. After we get these, then go for the derivative. Find f dash of x. But after finding f dash of x, we need to analyze f dash of x. So, if f dash of x is 0 for some values, we have to note them. If it is positive for some intervals, we have to note them. If it is negative for some intervals, also we have to note them. If f dash is not defined, these also we must be noting, because whenever f dash is not defined, we will get vertical tangents or vertical asymptotes. Okay. So, these are the cases. By observing all of these, we will be drawing the graph of the function. This is for general function, for any function. But because here polynomial function is involved, in polynomial functions, we do not need to do so much, because we do not get not defined values, we do not get asymptotes. So, we can straight away handle the function using roots and signs only. Okay. For example, here I am going to explain. If I factorize this function, what do I get? Y equal to x square, I can take it as common, and here I will get 2x square minus 1. So, what are the factors I am getting? X minus 0 whole square is one factor, 2x minus 1 is 1, root 2x minus 1, root 2x plus 1. Okay, these are the factors, and these are simple polynomial factors. Okay. So, how do we plot this graph? Just put the signs, you can do it with common sense. So, let me just draw it here. Let us say this is my x axis. Now, what are the roots? 0 is one root, other roots are 1 by root 2 and minus 1 by root 2. Now, signs. The coefficient of highest power is positive, so rightmost is going to be plus sign, and for this root 2x minus 1, the power is odd, so sign change will occur. For the factor x minus 0, see this x minus 0 factor, the power is even, so there is no sign change beside O. That means in the right side and also in the left side, both sides should be maintained with same sign. And for the other factor, which is root 2x plus 1, there is only odd power, so sign change will occur. So, with this I have put signs. What is the meaning of signs? Plus sign means graph is above x axis, minus sign means graph is below x axis. Now, further, because it is a polynomial function, function is going to be both continuous and differentiable, which means there are no sharp turns anywhere. So, I can just, by following these signs, I can just draw the graph directly. So, that means the graph is going to be somewhat like this, okay, because here 0 must be a root and both sides it is negative sign. So, it has to be a touch and go, graph has to touch and come back to the negative region only. See, with simple wavy curve signs, I have drawn the graph of fourth degree equation here. Now, in the question we are interested in ordinates of the points of minima. So, we have to anyways differentiate it, but this argument, this discussion will also be supported by the derivative. You can observe it. Suppose let us say if I take the derivative here, y dash. So, y dash will be 8x cube minus 2x. If I take 2x common, I will get 4x square minus 1. So, y dash is 0 at 3 values. One is x equal to 0, x equal to 1 by 2, x equal to minus 1 by 2. This means the point here where I am getting the minimum, this is going to be minus 1 by 2, and the point where I am getting the maximum, this point is going to be plus 1 by 2. Okay. So, this way also we can observe whether it is happening or how is it happening. So, using wavy curve method and using signs, we may get a qualitative graph, we will not exactly get the values. If you are interested in the output of this minimum value or the maximum value, you may have to go for the derivative and observe it where exactly it is taking the turn. Okay. So, we will discuss that little later, probably in the next lecture or next to next lecture. So, as of now you can understand that we are interested in finding the area between these two ordinates of this curve with x axis. Okay. So, basically there is a technique of finding the graphs, you can work out on this, and if you still have confusions, anyways I am going to discuss this in the next to next lecture. So, there also you can understand. Now, let me proceed with the current question. So, here basically we are interested in this area. Okay. Now, we can observe that in this function, if I substitute minus x in place of x, is the algebra changing? No, it is not changing. In place of x, if I substitute minus x, algebra is not changing, equation is not changing. So, hence graph is symmetric about y-axis. So there is already symmetry here for this function. That we observed by looking at the equation of the function only. Now because it is symmetric, if I find just one area which is let us say in the right side, and if I multiply that with 2, I can get the overall area. So basically my area will become 2 into integral of from 0 to 1 by 2, I am going to integrate the function which is 2x power 4 minus x square dx. Will this complete the process? No, there is a mistake. What is it? We did not check the sign. So because the function is below x-axis, integral is going to be negative. So make sure that minus sign is adjusted, and after this we just have to integrate it, and you know how to integrate this. Okay. So let us say if I integrate, what do I get? Minus 2 into 2x power 5 by 5 minus x cube by 3. Limits going from 0 to 1 by 2. We want to simplify this. So what are the values that we will be getting here? Minus 2 into 1 by 32, and there is already 1 by 5 here, right? And here we will get minus 8 by 3, sorry 1 by 8 by 3. Okay, so it is 1 by 8. Now here 16 comes. So to get 16 here, we can put 2 above. So 3 minus 10, it becomes 3 minus 10 by 5 into 3 into 16, right? Okay, so what do we get here? Here we will get 7 by 8 into 5 into 3. Okay, so that way we can find the area. So this will become the area of the required function. So here in this question we have actually touched many points. We have touched many conceptual points, and you need to have clarity of every point. So as I keep saying from the beginning, we always aim for perfection, we always aim for clarity. So if you need to work out on these ideas, and if you still have any confusions, I will discuss them again. Okay, come on, make a note of this. This page also. Okay, next question, find the area bounded by these two curves. Now we are coming on to the today's lectures concepts. So how do we do this? We have to draw the graphs first. So let me just explain you the process here. We know this function y equal to x square function, it is a parabola like this. What about y equal to minus x square? It is reflection about x axis. This is the graph. What about y equal to minus x minus 1 whole square? It is this graph which is shifted 1 unit right side. In place of x, if you get x minus 1, it means graph shifts 1 unit by right side. Okay. Suppose if x plus 1 is coming, so that means graph will shift 1 unit left. So basically this is the graph. Okay. So here I have explained the pattern. Now let me just draw the graphs of the question. This is, let us say, y equal to x square, and we have y equal to minus x minus 1 square like this. So this is our y equal to x square function, this is our y equal to minus of x minus 1 whole square function, and we have to find the area between the y axis, that means this is acting as one boundary, x equal to 2 is acting as another boundary, and these two curves are the other two boundaries. So basically we are finding the area which is bounded between these two graphs. So, how do we find the area here? Area is equal to integral of, so because I am using the concept of area formed with x axis, so limits must be on x axis which are going from 0 to 2, and when we are writing the functions we always write above function minus below function. So, x square minus into x minus 1 whole square dx. Now, when we simplify this we will get 0 to 2, x square is coming 2 times minus 2x plus 1 dx. So, you know how to integrate this. So, I will leave that simplification to you. Solving integrating a polynomial is very easy. So, I am leaving that to you. Okay. Come on, make a note of this. Okay. Can we proceed to the next question? Okay, next question. Find the area bounded by sin x and cos x between the intervals x equal to 0 and x equal to pi by 2. So, how to handle this question? Again, draw the graph, and graph is going to give you the clarity. So, let us say this is my y axis, this is 0, and let us say this is pi by 2. At pi by 2 output of sin x is 1, let us say this is 1, and at 0 output of sin x is 0. Excuse me. So, the graph will look like this. This is the graph of sin x. Now, let me draw the graph of cos x also. So, it will start from somewhere here and it will be like this. And we are interested in area formed by these two curves going from x equal to 0 and x equal to pi by 2. So, that means we are basically interested in this area. Now, if you notice, both are intersecting at this point where sin x and cos x are equal, and that angle must be 45 degrees, which is pi by 4. And also, because sin x and cos x are symmetric diagrams, this area also becomes symmetric about pi by 4. So, basically this part and this part are actually equal. So, to find the area, what we do is area is equal to 2 into, we will integrate only from 0 to pi by 4, and when we are integrating we have to take above function minus below function. What is the above function here? Cos x is above function. So, we have to write cos x minus sin x into dx. Now, we will simplify this. Now, what is the integral of cos x? It is sin x only. What is the integral of sin x? It is minus cos x, because there is already minus sign. We can put plus cos x here. Limit is going from 0 to pi by 4. Now, when I put pi by 4 here, I will get sin pi by 4 as 1 by root 2, cos pi by 4 as 1 by root 2, minus when I put 0, sin 0 becomes 0 and cos 0 becomes 1. So, if we simplify this, we are going to get 2 into 2 by root 2, which is root 2 minus 1. That becomes the area. Okay. So, here because of the symmetry, I have taken one area and doubled it. But every time we may not get symmetry. So, when there is no symmetry, we may have to take the other integral also separately. Okay. Come on, make a note of this. Okay. Can we move on? Okay, so here find the area bounded by y equal to x square plus x minus 1, its tangent at x equal to 1 and y axis. So how do we do this? Again same process. First we need to draw the graph. So let us draw the graph here. We know that this is a parabola because coefficient of x square is positive, it is an upward parabola. So let us assume that this is my upward parabola, and this point can be calculated using the formula minus b by 2a minus d by 4a. So here if I apply that formula, what do I get? A is equal to 1, b is equal to 1, c is equal to minus 1. So minus b by 2a becomes minus 1 by 2, minus d by 4a, what is d? D for discriminant. So it becomes minus 5 by 4. So this point is minus 1 by 2 comma minus 5 by 4. Okay. Now look at the coordinates. X coordinate is negative, x coordinate is negative. So that means y axis must be in the right side. So this is my y axis. Now look at the y coordinate. Y coordinate is also negative. So x axis must be above the point. So this is my x axis. This is my y axis. So here basically I have gone for very unconventional method. First I went for the graph directly, then I went for the axis system. Generally what we do is first we draw the axis and then we draw the graph, but I went for the graph first and then the axis. Anything is fine. Okay. Now at the point 1 comma 1, let us say 1 comma 1 point is somewhere here. At the point 1 comma 1 we have to draw a tangent. So because here the graph is increasing one, so the tangent is going to be somewhat like this. This is the tangent. Okay. So what is the area that we are interested in finding? Area formed with y axis and these two. One is tangent and other is the curve. So basically we are interested in this area. This is very slim area, but we have to find this slim area. So how do we do this? If we observe the graph, because all three boundaries are actually closing the diagram, so it is a closed diagram. We understand that one point. And from here, from this y axis till here x equal to 1, y axis means it is x equal to 0. So from x equal to 0 to x equal to 1, both curves are already present in the entire region. So I can go for above curve minus below curve idea. That means I am integrating with respect to x, because this is the idea of area formed with x axis. So how do we do it? Area is equal to integral of from where to where? From 0 to 1. Above curve is present, so x square plus x minus 1. And below tangent must be present. We do not know the equation of tangent, so I just left it vacant. Now how do we find the equation of tangent here? Two ideas. Because this curve is a second degree curve, we can always go for S1 equal to 0, or we can also go for finding the derivative and finding the tangent. Okay. So I will just go for the second idea. Here y dash becomes 2x plus 1. So when I put 1 comma 1, slope becomes 3. So equation of tangent is y minus 1 by x minus 1 is equal to 3, which gives me y equal to 3x minus 2, right. So that means here I have to put 3x minus 2 and integrate it. Okay. So now here in this question the main step is to understand the diagram and the bounded area. Even if it is very slim, we can always find area, but we have to put appropriate signs here. Okay. So now if I simplify this, what do I get? X square minus 2x and plus 1 dx and it's going from 0 to 1. Luckily this has become a perfect square. Okay, so we can go for perfect square, which is x minus 1 whole square here. So integral will become x minus 1 whole cube by 3, limits going from 0 to 1. Okay, is this fine? So let's see what happens. So when we put 1 by 3 is outside, so when I put 1, it becomes 0 cube. When I put 0, it becomes minus 1 cube. So overall we are getting 1 by 3 as the answer. Okay. So that way we can evaluate this integral. Okay. Come on, make a note of this. Let's look at another problem. So here we have to find the area bounded by these two curves. Now how do we draw the graphs of these kind of functions? Here again we can use the idea of wavy curve method and find the graphs. For example, let's say I take this function. Okay. So here I will just explain the graphs only in this page, and in the next page I will solve the question. Here if I factorize it, I will get two factors, y and y minus 1. That means when y is equal to 0, output becomes 0. Take output on x axis, take input on y axis. Okay, so let's deal it this way. So on y axis we have inputs, on x axis we have outputs, and when x is equal to 0, when y is equal to 0, x is 0, and when y is equal to 1, x is 0. This is my y axis. Now let us put signs. Because the highest power is having plus sign, the uppermost region is going to be of plus sign, and then signs will be alternate. So here it will be minus sign, here it will be plus sign. So that means the graph will be somewhat like this. This is the required graph. Okay. So here we got one graph. Now look at this function. What is the difference between these two functions algebraically? Here if I just take one minus sign common, it looks like minus x equal to y square minus y. Now if you look at the original function and this function, what is the difference between these two? Minus x is coming in place of x. That means graph should be reflected about y axis. So that means if I reflect this graph about y axis, I will get the second graph. So here if one graph is like this, the other graph will be reflection of this graph about y axis. This is the second graph. See how beautiful it is. If you understand this meaning of changes in signs algebraically with respect to the geometry, you can understand everything very beautifully. Okay. So here by observing these patterns, I have drawn the graph, and also I have used the idea of wavy curve method to draw the graph. Now I am interested in area bounded by these two. What is the area which is completely bounded by only two curves? That means all boundaries must be only these two curves. So which is the area I am talking about? I am talking about this area. Okay. Now why did I mark it in different styles? Because it is symmetric about the y axis. If I calculate one area and if I double it, I will get the overall area. Okay. So now which function to take? I will take the right side function. Which is right side out of these two? In this interval, out of these two, blue and red, which is in the right side? Red is in the right side. So that means I am basically taking this function. Okay. So my area is going to be 2 into integral of x dy and limits going from 0 to 1. Now what is the expression for x? We will write y minus y square. So it becomes 2 into integral of y minus y square into dy, limits going from 0 to 1. I think this integral is very simple integral. What do we get here? 2 into y square by 2 minus y cube by 3. Limits must go from 0 to 1. So if I put 0 there, okay, so area is equal to 2 into, if I put 1, I will get 1 by 2 minus 1 by 3. If I put 0, I will get zeros only. So basically I will get 2 into 1 by 6, which is same as 1 by 3. Okay. So this way we can solve this problem. Okay. Come on, make a note of this. Okay. Can we move on to the next problem? Okay. Next, find the area enclosed by these two curves. So here if you notice, enclosed word is used. So that means area is completely closed diagram. So there is a line given, there is a curve given. We have to draw the curve, we have to draw the line and then see where the area is enclosed. Okay. So how do we do that? So for that, first we will draw the graph here. This is quadratic, so it is a parabola. Coefficient of x square is positive, so it is upward parabola. And this point is going to be, we know the formula, minus b by 2a comma minus d by 4a. So minus b by 2a becomes minus 1 by 2, minus d by 4a becomes 3 by 4. Now x coordinate is negative, so y axis is in the right side. Y coordinate is positive, so x axis is below the point. So this is my x axis, this is my y axis. Okay. So for quadratic graphs I follow this technique so that it becomes faster. Okay. Now looking at this line, y-intercept of this line is 3, that means it has to pass through 0, 3. Slope is 2 units. So the graph is going to be a straight line which is having slope 2 units and which is passing through this point which is 0, 3. Okay. So for rough location we need at least one point, otherwise we cannot be sure of the orientation of the line. So now the line is intersecting the curve at 2 points, and what is the area enclosed by these two? Here if you notice, these two are indefinitely stretching, area is not enclosed. This part is also not enclosed because both are open ended. Here also it is not enclosed. So enclosed region is only this. Okay. So this is the only enclosed region. Now how do we find the area here? Again same idea, above curve minus below curve and then just integrate it. But we need to identify the limits. So limits can be calculated by solving the curve and the line to get the values of x here. So for that we need a basic simplification or solving process. So how do we do that? We equate these two functions and we solve for x. So what do we get here? X square minus x minus 2 is equal to 0. Now if I factorize this, I am getting two factors, x minus 2 and x plus 1. These two are the factors. Now x equal to minus 1 is one root, x equal to 2 is one root. So I got the limits. This is minus 1, this is 2. It is geometrically also fitting and convenience, it is satisfying. Okay. Now how do we find the integral here? So area is equal to integral of, what are the limits? Minus 1 to 2. What is the above curve? 2x plus 3 is the above curve minus what is the below curve? x square plus x plus 1 is the below curve. Okay. So, now let us proceed with the integral here. Minus 1 to 2, we are getting 2x minus x, 3 minus 1. So, 2 plus x minus x square dx. Now, what will be the integral here? It will be 2x plus x square by 2 minus x cube by 3 and limits going from minus 1 to 2. If I put them here, we will get 2 into 2 plus 1 plus 1 by 2 into 2 square is 4 minus 1 square is 1 minus 1 by 3 into 2 cube is 8 minus 1 cube is minus 1. Now, just simplify this. So, what do we get here? Here we will get 6 and here we get 3 by 2. Here we get 9 by 3 which is same as minus 3. Okay, so luckily the numbers have become very simple numbers. 6 minus 3 is 3. 3 plus 3 by 2 is basically 9 by 2. Okay. So, the area here is 9 by 2. So, this way we can solve the problem with ease. Okay. So, here if you understand what is the main idea is the diagram only. In almost all questions of the area under curve chapter, the main step is the diagram only. So, if your graph drawing techniques are weak, you have to go back and learn those techniques one more time. You have to master those techniques and only then approach this chapter. Okay. But if you observe, 90% of the questions that come at a simple level, let us say 90% of the questions in the chapter are of easy graphs only. So, that means in CET and in mains level, questions will come only from that 90% where drawing graphs is easy. But when it comes to advanced level, questions will come from those 10% of the questions where drawing graphs is actually confusing and area is also confusing. So, that is why you need to learn the techniques of the graphs. But without learning much techniques also you can master mains level, that is simple only. Okay. So, with this question we will close today's lecture. We will meet again in the next lecture with the remaining problems and also with a new technique in area under curve. Until then, have a great learning day. Learning shall never stop.